Hey, have you ever wondered how we get real, on-the-ground data about a place? It's not as simple as just going out and asking a few questions. Today, we're going to jump into a geographical fieldwork mission using a real-world case study from Antigua to see how researchers turn a big, broad question into concrete, reliable answers. Let's dive in.
Okay, so our mission takes us to this absolutely beautiful UNESCO World Heritage Site in Antigua. Now, the researchers here, they want to understand tourism on two totally different scales. First, you've got the big picture, the macro view, which is all about analyzing long-term trends. Then they zoom all the way into the micro level, tracking what individual visitors are actually doing inside the park. It's really about connecting the dots between huge trends and personal choices.
You see, to get a grip on what's happening on the ground today, you've got to look back. You have to understand the bigger picture from the past. All good fieldwork kicks off with this macro view to really set the stage.
And this is where it all begins, with the raw data. This table right here, it tracks the ups and downs of tourist arrivals over a decade. And you can see it's a total roller coaster, right? Look at that huge dip back in 2009. This isn't just a boring list of numbers. This is really the opening scene of our story. But now, look what happens when we turn that data into a picture. Bam! It instantly tells a story. We see this really painful 12% drop in 2009, which, was likely tied to the global financial crisis, and then this steady, hard-won climb back up to a solid 8% growth. That's the power of visualization. So, what was the total swing from the very bottom to the top? Well, to figure that out, we need to do a little bit of geographical math. And a great way to think about it is like a thermometer. We're not just looking at the final number, we're measuring the entire journey, all the way from that chilly minus 12% up past zero to that warmer plus 8%. And the calculation itself is pretty simple. You take the final value, 8%, and you subtract that starting value of negative 12%. And of course, if you remember your middle school math, subtracting a negative just means you add the positive. And there it is. The total difference in percentage points over that decade is a whopping 20%. So that's our macro context. It's a story of a pretty significant recovery and growth in Antigua's tourism. Okay, so we've got the big picture. We know the backstory. Now it's time to zoom in. How do we go from that broad 10-year data to a really specific question we can actually test on the ground? This right here is the crucial step. This is what turns just looking around into actual science. How do you take a general curiosity, something like, I wonder where tourists go in the park, and forge it into something you can actually prove or disprove with data? Well, a strong hypothesis isn't just a random guess. It's an educated, structured prediction, and it needs two essential ingredients. First, you need a measurable threshold, and second, you need a specific variable that you're going to compare. These two things work together to create a question that has a clear yes or no answer. So, let's talk about this measurable threshold. This is so important. Vague words like most or a lot, they're totally useless for research. You need a hard number. By setting a specific value like at least 75%, you create a clear line in the sand. If your data comes back at 74%, nope, the hypothesis is rejected. If it's 75% or higher, it's accepted. See? No gray area. And here it is, our complete, well-formed hypothesis. Let's break it down one more time. At least 75%, that's our measurable threshold. Visitors went to attractions, other than the dockyard, that's our specific comparative variable. See how perfectly it works? It's precise, it's testable, and it sets up the entire rest of our fieldwork mission. All right, with a solid hypothesis in our pocket, it's time to get our boots on the ground. But how do we actually collect the data to test this thing? This brings us to the very practical challenge of sampling. So picture this. This is the scene of our data hunt. On the left, we've got the park map, showing all the different sites. And the question is, are visitors actually going beyond the main dockyard? Especially when, as you can see on the right, there's a sign at the exit literally encouraging them to explore more. The plan? Survey people right at this exit point. Now, this method of just grabbing whoever is easiest to talk to, it has a name. It's called convenience sampling. And yeah, the name says it all. It's fast, it's simple, and it's, well, really convenient. It seems like a perfect solution, right? Super easy. But in research, the easiest path often has some hidden traps. What could possibly go wrong with just asking people as they're leaving?
Well, here are the risks. The people you survey might not represent all the tourists. For example, maybe families with young kids leave earlier in the day, or maybe big tour groups all leave at the exact same time. By only sampling in one location at one time, you could get a really biased sample, and that makes your final results totally unreliable.
So, our data might be flawed. Does that mean the mission's a failure? Do we just pack up and go home? Absolutely not. The next step for any good researcher is to recognize these potential flaws and then put strategies in place to fix them. You got to make sure the data is as reliable as possible.
So, to fight back against the bias of convenience sampling, we can use two really powerful techniques. Think of these as our fixes: spatial sampling and temporal sampling. Let's break these down, because they're pretty cool. Spatial sampling is all about fixing the where. So instead of just that one exit, you survey people at multiple spots all around the park. That way, you capture different types of visitors. Then, temporal sampling fixes the when. You don't just survey on Tuesday at noon, you survey in the morning, in the afternoon, on a weekday, and on a weekend. When you use them together, these methods paint a much more accurate and reliable picture of what's really going on.
And that brings our fieldwork mission to a close. So let's do a quick debrief and lock in the most important lessons from this whole process.
So, what did we learn? Well, we've basically uncovered a 4-step blueprint for solid geographical fieldwork. First, you start with the macro data to get the context. From there, you craft a measurable hypothesis. Then, you have to be really honest about the limitations of your sampling method. And finally, you use fixes like spatial and temporal sampling to make sure your results are truly reliable. And I'll leave you with this final question to chew on. We've controlled for location and time, but what about other variables? I mean, how would the results of this survey change between the peak tourist season and the off-season? Or on a rainy day versus a sunny one? It's a great reminder that in geographical research, there's always another layer to uncover.